Hi, welcome my amazing students to another algebra lesson. So we're going to be going over 5-7a, slopes of parallel lines. So that's the title of this one. And yes, all right, so now that you have this all copied down, let's just quickly go over what it is. So we have parallel lines. So parallel lines are basically pretty simple. It's two lines, here we got, that never cross, right? So that's huge. They never cross, and they have, and this is the key, the same slope, all right? So again, it was so important I wrote it a second time, that these two lines will never intercept, and they must have the same slope. That's what it means to be parallel, all right? And we're going to be using this formula because if it's written in this form and in this pattern, the thing in front of the x will be our slope. So any number in front of x will be slope if it's in this y equals mx plus b form. All right, so here's example one. It's a two-parter. There's part A and there's part B. If you want to separate them with a little squiggly line, go ahead. Take a moment to copy down this instructions and copy down these two equations. So just hit pause and do that right now. All right, so what does the instructions say? It says given two lines, right, are parallel. So basically I'm telling you that the lines are going to be parallel. So that means they're never going to intercept and they're going to have the same slope, right? Because that's what parallel means. So given that the two lines are parallel, tell the slope of the second line. Well, this is how easy this is. If we use our handy-dandy slope-intercept form, y equals mx plus b, and make sure that it's in that form, and both of these are, yay, we simply identify the slope. Well, the slope on this one is -7. The slope on this one is positive 5 over 2. So that means that the slope of the second line is going to be, on this one, -7. The slope of the second line for this one is going to be 5 over 2. I might not know anything about the second line, but I can definitely tell you that they're going to have the same slope because I told you that they are parallel. So that's a pretty easy example one. So we're going to move on. All right, here is our example 2. So it says, tell if these lines are parallel. So hit pause again for a few seconds. Write down the instructions and write down A with these two lines and write down B with these two lines. So do that right now. All right, so these are copied down and we're trying to figure out if these lines are parallel. First, we want to make sure, are they in the y equals mx plus b? So I'm going to write that right above here, y equals mx plus b, y equals mx plus b, right? Because if they're in this form, yay, it looks like they are, then the number that's in front of the x is my slope. So, are these the same? -3 over 2, -3 over 2, yes, these have the same slope. So these are parallel. Pretty easy. Okay, same. Now, let's look at this one. Are this the same? Because let's be honest. These two equations look almost identical. It says y equals 4x minus 7, y equals -4x minus 7. So even the rear ends are the same, but are the slopes? This is a +4, this is a -4. No, they are not the same. That's not an H, that's a no. They're not the same. So that's how you tell if two lines are parallel. You just make sure that they're in the slope-intercept form, and you compare the number in front of the x. If they're the same, yes. If they're different, and yes, one being positive, one being negative, means they're not the same. All right, so that's if they're in this formula. So make sure that you have number 1 and number 2 all copied down, and now we're going to go on to number 3. All right, so number 3 is basically asking the same thing. It's showing me two lines, and it's going to ask me, are they parallel? Just like example number 2, right? So if you need to, hit pause for just a moment and write down those two equations. All right, so now that you have those written down, is, well, we take a look and I got, oh, it looks like I got a 5 and I got a 5 over 2. The answer is no. These are not parallel. But stop. Are they in the y equals mx plus b form? This one is. Good. Check. What's the slope of this one? The slope of this one is, according to this, 5 over 2. That's my slope. I know it because it's in the right form. But if I come over here, y equals mx plus b, no, this is a red flag. This 5 is not the slope. That is not the slope because it's not in this form. So we have to change this equation to match this. So we're going to do that right now. So I'm going to draw my dividing line at the equal sign. I'm going to move I don't want my x over here. According to this, my x has to be on this side. So I'm going to go minus the 5x, minus my 5x. That means I'm going to drop down my negative 2y, keep that negative, put my equal sign back. Now, negative 5x, that has an x. That 8 does not. These do not get combined. So it becomes negative 5x minus 8. Right? So make sure that you don't accidentally come up with minus 3 or 13. You don't add or subtract these. You just write them down. Then, I'm closer, but is the y by itself? No, the y still has this negative 2 in front of it. That is not allowed, so we got to get rid of this. So divide by negative 2. Divide by negative 2. Divide by negative 2. So now the y is by itself. That's looking good. See how it matches? Now that's a negative 5 and a negative 2. You should know by now that two negatives make a positive, so it becomes positive 5 over 2 x. And then negative 8 divided by negative 2 is a positive 4. Now, once this has been changed into this form, I can say that this slope is 5 over 2. And look at here. They do have the same slope. So the answer is yes. These two lines that we were given, this 5x minus 2y equals negative 8, and the y equals the 5 over 2x minus 14. Once I change this into the y equals mx plus b form, I found out that their slopes are identical. That means these are parallel. Okay, so we have two more examples. So make sure, if you need to, hit pause and get this all copied down. All right, so here is example 4, and yes, it has it's a really long instruction, so make sure to hit pause right now and copy down the instructions and the beginning of the problem. All right, so now that this has been copied down, let's go through it. It says, first of all, write an equation, right? Well, what does that mean? That means you're doing this. You're writing an equation of a line passing through a given point. What do I mean by a given point? Well, that's what this is right here. This is my given point. I'm giving you it. It's negative 3, 1. And is parallel to a given line. Well, what's the given line? Here's the line. Y equals negative 3x plus 5. And look, I was so nice. I made sure that it was in this slope-intercept form so that I know, all right? And you're going to love this. Why? So how do we solve this? Step 1. Label. All right, and what are you going to label? You're going to need to find an x1, a y number 1, and our slope. So there's step 1. So x1, y1, and where's my slope? Oh, that's right. Y equals mx plus b. What's my slope? It's my -3. Alright, so there's my labeling. -3 is my x1, 1 is my y1, and then I have another -3 that happens to be my slope. So what is my second step? Alright, so on the second step, we're going to use something called the point slope form. Point slope form. Well, why? Because I have a point, here it is, and I have a slope, there it is. So what is the point slope formula? Well, again, this should not look new. Y minus y1. Do I have a y1 somewhere? Oh, I do. Equals, do I have a slope? Yes, I do. It's that -3. Then I got this x minus, and then it says x1. Do I have an x1? Yes, I do. It's right there. So I'm going to write this again over here. So y minus y1 equals mx minus x1. And this is why we labeled. Is, plug it in. Y minus, what's my y1? 1. Equals, what is my slope? My slope is -3. X minus, and what is my x1? There it is, -3. I even made them in red for you. So, step 2 is extremely important that you use the point slope formula. So we're going to be using 2 formulas. All right, so with that being said, I still have to get it into which form? I got to get it into this formula right here. So, I'm going to take this, and now I'm going to do my math. Now remember, we have y minus 1. That's my -3. Then I have my x, but I do not like having a minus sign next to a negative sign. So since I have a minus next to a negative sign, I can clean this up and make that a plus. This is the only time I make this a plus, is because this is a minus sign and this is a negative sign. Alright, so now I'm just going to start solving for y. So what do? I'm going to distribute the -3 to get rid of the parentheses. So that changes everything. So that becomes -3x. And then -3 times +3 is a -9. I'm going to go drop this down, y minus 1. Am I in my y equals mx plus b form yet? No, the y is not by itself. But on this one, it doesn't have anything in front of the y, it just has this +1. I mean this -1. So I'm going to use +1 to get rid of it. And I'm going to put it under the 9. So I get y equals, drop down the -3x, and then in the calculator go -9 plus 1, you get a -8. And what did you just do? You just created an equation. I'm going to move it down a little bit. You just made an equation right here of a line, that's a line, that it's going through this point and is parallel to this equation. And you can compare them, right? -3x, -3x, right? So, boom. That is basically the end of this lesson. Number 4 is by far the hardest part, so make sure you listen to that more than once, and have a mathtastic day.